Hello again everyone, this is Mr. Hoy. In this video we're going to be reducing radicals that also have variables. In previous videos we've talked about how to just reduce your integer terms here, so root 288. Here we're going to add in x to the third and y to the eighth to the problem. The 288 is handled exactly like you would otherwise. Basically you want to look at this as the square root of 144 and the square root of 2. In this problem, we simplify the root 144 and make it a 12, and we can leave the root 2 in the problem. So we can leave some spacing here. I'll put the 2 there. Now, for the rest of the problem, what we want to do is remember that the square root of something is the same as taking that same something to the 1/2 power. So when you're doing this question, a way to think of it that's a little bit cleaner is you're going to be taking a half of each of these exponents. So we'll start with the x to the third. Half of x to the third is 1 1/2. So what that means here is that you're going to take one of the x's and bring it out here. Think of this as an x to the first. And the 1/2, you want to think of it like a remainder. So you're essentially dividing 3 by 2, getting 1 with a remainder of 1. So there's going to be 1 remaining x inside the radical. With the y to the eighth, a little bit cleaner, you can just divide 8 by 2, or take 1/2 of 8, and get 4, and you're left with a y to the fourth out here. And you have no remaining y's inside. So again, to recap, the numbers that are here you're dealing with as you would normally. So this is 12 root 2, and the variables inside, you're simply going to take their exponent and divide by 2, leaving any remainder inside the radical. So for odd numbers, anytime you divide an odd number by 2, you'll have a remainder of 1. For even numbers, anytime you divide those by 2, you'll have no remainder. So in this case, there's no remaining y's under the radical.